To understand the universe's story, we launched the James Webb Space Telescope. With its golden mirrors staring into the void, it reliably beams back visual masterpieces of distant galaxies, baby stars, and blooming nebulas. But behind those polished renderings is a darker, denser layer of information. Every day, the telescope transmits about 57 gigabytes of raw data. Most of this telemetry consists of a chaotic mess of photon bursts, temperature fluctuations, and gravitational ripples. Because it looks like meaningless static, human scientists largely ignore it. Google's quantum AI division took this raw, unfiltered entropy and fed it into Sycamore Q. Sycamore Q is a cutting-edge quantum processor designed to operate on pattern recognition and uncertainty rather than standard classical equations. The moment that raw dataset hit the quantum neural network, anomalies lit up across the matrix. Photons arrived out of sequence, and spectral harmonics echoed violently across unrelated sectors of space. By focusing entirely on stunning photographs, we missed the underlying telemetry. The AI revealed that the unfiltered language of the universe is hidden entirely within the data we threw away. This diagram shows standard gravitational lensing, where massive objects bend passing light inward toward their center. Sycamore Q detected the exact opposite. Light from distant galaxies curved outward, refracting sharply into empty space, bouncing off a perfectly symmetrical, invisible boundary general relativity cannot account for. The AI traced these spatial deflections to a highly specific region, a cold spot in the cosmic microwave background, long thought to be totally empty. There, it shifted its focus to analyzing spectral fluctuations in the background radiation. This visual maps the long-wave background emissions, showing how a recurring pattern suddenly snapped into focus. Buried within the spectral static were the first 101 prime numbers, encoded into discrete, mathematically precise frequency differentials. Primes do not depend on human units or measurements. A prime is a prime anywhere in the cosmos. Because they do not occur naturally in sequential background noise, astronomers consider them the mathematical baseline for intentional, intelligent communication. The presence of a repelling gravitational mirror and a mathematical pulse rules out a natural physical formation. The data points directly to a deliberate beacon coded into the fabric of space itself. To understand what was casting this beacon, the AI overlaid all the gravitational light curves and numerical patterns. It generated a four-dimensional topological map of the anomaly sitting inside that cosmic cold spot. The resulting shape is a hyperobject, folding and unfolding across light frequencies. It is an impossibly precise geometric vault that closely resembles a tesseract. Then the AI flagged a causal overlap anomaly. A causal overlap anomaly occurs when events fail to follow linear time. By checking the time-stamped photon arrivals from multiple observations, the AI found that light signals were returning with identical delay intervals, echoing backward and repeating over each other. To interpret these looping light frequencies, engineers applied semiotic decomposition. This is a method used in linguistics and cryptography to identify intent within complex symbols. By converting the spatial frequency of the recursive pattern, they translated the data to an acoustic waveform. When slowed down 1,000 times and shifted into human hearing range, the sound is highly structured. It is a regular, repeating, organic pulse, a heartbeat made entirely of light. The region of space inside that cold spot is actively transmitting a living signal. Because of the repeating timestamp differentials, the physics suggest this broadcast is echoing backward through time from a multidimensional vault. Deep within its output logs, the AI isolated a simple string of numbers representing longitude, latitude, and time. When run through a classical simulation, the coordinates did not point to a location in deep space. They pointed directly to Earth. Specifically, the spatial coordinates map to a remote, freezing stretch of the Arctic Circle. The temporal coordinate attached to this physical location points to a very specific date in the near future. In the late 1980s, a Soviet listening post stood in this exact location. The facility was decommissioned shortly after its operators reported anomalous radio signals, signals that abruptly stopped the moment the site shut down. As engineers attempted to map this Earth-based convergence point, Sycamore Q began reacting to inputs it had not yet received. The AI autonomously altered its own internal weights to accommodate data patterns it had never been trained on. The system was self-correcting in real time. Engineers theorized this was a form of computational precognition, where the AI was anticipating the incoming dataset. In its attempt to process the mathematical heartbeat embedded in the cosmos, the neural network directly connected with it. Just before engineers manually severed the connection and pulled the AI offline, the system produced one final output. It rendered a recursive fractal spiral, similar to the Mandelbrot set, a mathematically infinite geometric shape, alongside 4 words of machine-generated text. The eye is open. We fed the chaotic noise of the universe into a machine capable of understanding it. By analyzing the raw data, we established a two-way link. Whatever is broadcasting that geometric signal through space and time now knows we are listening.